Okay, here we go. So we're going to talk about chapter 3, which is the normal distribution. Now we've talked a little bit about it, but we're going to go into big detail in chapter 3. Okay? So the normal distribution is the most common type of data. Okay? It's actually called the Gaussian, G-U-A-S-S-I-A-N distribution. This is a funny story, okay? It was discovered by a guy named Gauss, and he had a mathematical rival, and the mathematical rival didn't want to call it the Gaussian distribution. He goes, that's just normal data, and the normal stuck, but if you get into the math, they call it the Gaussian distribution.
Well, what does that say that the
Gauss, that's the name of the guy. Okay. So we can use the normal distribution on non-normal data. So it's extremely useful. Okay. Now, you're all familiar with the bell curve, right? Okay. Would you like to see the equation that makes that bell curve?
Yes.
I think that was the wrong answer, but here it is. Y equals the integral from negative infinity to infinity of 1 over square root of 2 pi sigma squared e to the minus x minus mu squared over 2 pi sigma squared square rooted.
You didn't do that so fast.
Dx. You don't need to know that because it's calculus.
Oh, okay, good. So we don't have to know that equation.
So if you want to find the area between any 2 points, all you have to do is integrate it between the 2 points. But you didn't take calculus, did you?
Nope.
And integrating that's not very fun, I'll add. So we're going to find a way around that, okay? But I just thought I would share that with you so that you can go, wow, I'm so glad I don't know calculus. Okay? So the rules, number 1, or what we call A, the area under the curve equals 100%. Okay? Which makes sense.
But this is rules for the bell curve.
This is the rules for the bell curve. Okay. B, the mean equals the median. Okay. And it's usually centered here. We will use mu, the Greek letter mu, for the population mean, or we will use x bar for the sample mean. Okay. So remember, when you ask me on the test, is it comprehensive? And I say, well, you still need to know if stuff is a sample or a population, so that you know which letter to use. Okay?
What does A say?
What does A say? The area under the curve equals 100%. Okay? Part C, the curve is symmetric. Okay? And because it's symmetric, if I were to draw this line right up here, how much is on each side?
50%.
That would mean you'd have 50% on each side. Because that's also the median, right? Okay. D, the mean, mu, and the standard deviation, sigma, completely define curve. Okay? And so once you know that, we can do some stuff without having to know calculus, which is nice, right?
So after standard
Who's bummed that you
deviation,
don't have to know calculus?
and the standard deviation, is that a square root or what is that?
Oh, that's the Greek letter sigma.
Oh.
It looks like this, okay? This is also the Greek letter sigma. Those are both the same letter.
Okay.
I've taught you that before, haven't I? Yeah, I thought I had. All right. So let's talk about one of the, because you don't need to know calculus, shall I erase that equation you'll never use in this class? Erase from your brain now, right? Okay, so we've got a rule called the 68, 95, 99.7 rule. I think we've talked about that before, right? Okay. What do you remember, Colin, about the 68, 95, 99 rule?
That within one standard deviation, you have 68% of your data. Within two, 95%, and within
You're going
three.
too fast. Okay, so 68% of your data within one standard deviation.
Yes.
Two
Is 95%.
95% of your data within
Two
standard deviations, and
99.7%.
99.7% within
Three.
3 standard deviations. Okay, so we knew that on the last test, so we can't forget it. Okay. All right. So let's say, for example, let's do an example. I want you to draw a bell curve that illustrates these things. Let's say that women age 18 to 24 have a mean height of 65 inches and standard deviation of 2.5 inches. So I want you to help me draw a bell curve in which you give me all those numbers for the 68, 95, 99 rule. Can you do that for me, Kensley?
Maybe.
Maybe. How about if I help you? Okay, what's the middle number here?
65.
That's 65 inches, right? Okay, and we're going to go out 1 standard deviation. And how much data should be within 1 standard deviation?
To be the 68%.
68%. Now I need to figure out what these two numbers are. Do we know what that number is?
It's 62.5, right?
62.5, right? Because the standard deviation, so we're going to subtract 2.5. And this number here is
67.5.
67.5. Okay, who's studying with Kensley tonight?
I should.
Oh, we shouldn't? Okay, what's the next number here?
60.
60 and
70.
70. And between those two numbers, we have
95.
95%. And one more standard deviation,
57.5.
57.5 and
72.
72.5. We have
The
99.7% of the data. Have you met any, by the way, this is 6 feet a half an inch, right? Have you ever met a 7 foot tall woman before?
No. Yeah, I have.
I have. Who did you meet?
There's this family that, like, where my dad's work, and all of their kids. I've seen one of them. He'd be super, super tall, lanky guy. Maybe someone's seen him walking
I said
around.
a woman, not a guy.
Yeah, but his sisters and his parents, everyone in the family is the exact same. They have that same disease. They're all super, super tall and skinny. They're like
And they're
punching
7
under
feet
the
tall?
doors. Probably over 7 feet tall.
Wow. So I used to work for the Utah Stars. You guys remember the Utah Stars women's NBA basketball team?
Yeah, no, it's the guys, isn't it?
So the Stars with an S is the guy, with the ZZ is the women.
Oh, okay.
Okay. And there was a woman, Margot Diedick, she was 7'2", I think. Yeah, she was huge. She actually died in childbirth. It was terrible. But yeah, she was way out here. She was in the 0.3% of women. So not very many women that I look up to, but I looked up to her.
Oh, wait, so
I
that's,
did date a girl that was taller than me one time.
that 65 inches is like an actual average. You didn't just pull that number out like
You
that.
used the A word.
Of the mean.
The mean.
I was like, what A word did I use? We're good. We're good. Yes, the mean. So
Yeah,
is 65
so
inches
the
like an
mean-
actual mean for like the general?
I don't know if that's correct, but this is a good example. I think it's pretty close. 65 inches would be about 5'5", and that seems about pretty normal, right? Okay. All right. So what's cool about this is, I'm going to erase this now. Okay? I told you you didn't need to. I told you that you didn't need to know calculus, right?
Yes.
Okay? So one of the nice things about is that any normal distribution can be converted to a standard normal distribution with this equation. Okay? Now, in the book, I'm going to actually give you two equations. In the book, I'm pretty sure they give you the equation z equals x bar minus mu over sigma. That's what the book gives you. In a future chapter, they're going to give you another one. And it's going to be very similar. It's going to be z equals x bar. No, actually, they don't put a bar over there. X bar minus mu over sigma over the square root of n. And then students are going to say, well, which one do you use? Okay, because one has an x, one has an x bar. They're very similar. Okay, I say use this one. Okay, the fact of the matter is, if your n is 1, this equation becomes almost identical to this because the square root of 1 is 1, right? So if your n is 1, these two equations are basically the same, right? Okay? So here's what I would say. If n is given, use it. If it's not given, assume that n equals 1. Okay? And so then, even though this is the one they give you in this chapter, because n is always 1 in this chapter, I just want you to get used to this because we're going to use it in a future chapter. Okay? And just remember that n is 1 in this chapter. Okay?
What's the bottom half of the equation?
This is the letter sigma divided by the square root of n.
And sigma is standard deviation.
Sigma is your standard deviation.
Divided by the square root of n?
Right. Okay? So let me give you an example here. We're going to pick on Brady. Brady scored 600 on the SAT exam.
Oh, is that good? I don't even know.
Which is normally distributed with a mean of 500 and standard deviation of 100. Okay? Now we're going to pick on Suzette, scored 21 on the ACT exam, which is also normally distributed with a mean equal to 18 and a standard deviation equal to 6. Okay? Who did better? Okay? So one of the nice things about this is just this equation I just gave to you, okay? You all know that the ACT and the SAT exams are college entrance exams, right? They both kind of measure the same thing, but they use wildly different grading scales, right? Okay? So the idea here is, what I can do is I can convert, and I probably should emphasize the word standard normal distribution, okay? Because I can convert those. In fact, I guess I should have told you about the standard normal distribution, okay? The standard, there we go. Standard normal distribution always has a mean equal to 0 and a standard deviation equal to 1. And so what we can do is we can convert Brady and Suzette over to a standard normal distribution, and then we can compare them directly and see who did better. Okay? So, with the standard normal distribution, what is the mean? It's a favorite test question, too.
0.
0. And I love to ask the question because people ignore the word standard and they go, I don't know, you didn't tell me yet. You should know it's always 0. Standard deviation is always 1, right? So within one standard deviation, we have how much data?
68%.
68%. Okay, so what we're going to do here, I'll pick a different color, and we're going to map Brady's score onto the standard normal distribution. So we'll use black for this one. Okay? So Brady, can you convert your score to a standard normal distribution?
Yes.
Okay? So Z equals,
The mean, which is.
no, it doesn't equal the mean.
It's X bar.
X or X bar. What is your X or X bar?
Isn't that 100?
Nope.
I don't know what it is.
Okay. Well, we know that sigma is 100, right? It's
Yeah.
right there. So that can't be X bar. So the 100 is going to go in the denominator, right?
Yes.
And we got a mean of 500. What do you think that, what letter is mean?
Mean is the M.
It's actually a mu. It looks more like a U with a tail. Yeah. So we're going to subtract off what?
100.
500. The mean is 500, right? Okay. And what do you think the X is?
It's the 600?
Oh, there we go. Process of elimination, right? And how many Brady's are there?
1.
There's only one. Okay, 600 minus 500 is
100.
100 divided by 100 equals
1.
1. So actually Brady is right here. Okay. All right, Suzette, can you help me? If I pick another color like red, can you help me figure out how you did relative to the standard score? So Z equals 21 minus 18 divided by 6, and how many Suzettes are there? There's only one. Okay, 21 minus 18 is 3 divided by, shh, you're not Suzette. 6 equals, what'd you say? 3 divided by 6 is what? 0.5, 0.5. Okay. All right, so Suzette, you're 0.5 standard deviations away. Who did better? Brady did better, right? Brady's got the better score relative to Suzette. Okay. Now, the question is, now Brady, the first question he said was, is that a good score?
Yeah, is that a good score?
Is that a good score?
Yeah.
Now, the one thing about this, if the whole area under this curve is, okay, we know that 68% is less than Brady, but how much is over here? Because it's 68% between those two, but how much is over here?
16%.
16%, right? Because you've got 16% here, and you've got 16% here, right? So if I take this 16 plus that 68, that gives me what? 84%. So you can say that's the 84th percentile. Brady did better than 84% of people. Is that a pretty good score, Brady?
Yes.
Would you take that on one of my tests, an 84?
Oh, heck yes.
Heck yes. Okay? So that's pretty good, right? Now the problem is Suzette doesn't fit on one of my nice 68, 95, 99 rules, right? And Suzette still wants to know if she did well, right? Okay, so we want to figure out what percent of your data is less than there, and we don't want to do calculus, right? Who wants to do calculus? Landon, you didn't raise your hand this time.
Yeah,
Okay, so in your book, well, I'll show you, I'm going to show you on the computer here in a second here. But in your book, I can't remember if it's in the front or the back. It is in the front. No, that's T. Never mind. I don't know why they make this hard to find. Okay. In the back of your book, you've got these tables here. Okay. So you can do your homework with these tables. I also, just for fun, created that table myself all on a spreadsheet so that I can show you guys. And this is the table because it fits on one page rather than two. And so you remember on the last test, I gave you a bunch of formulas that you didn't even need to know, right? Okay, so here we go. We've got the random number table, we got the normal distribution table, we got the t-table, which we will be learning later. We've also got the chi-squared table that we will be learning later. Okay, so I put these all together, okay? So this is what we refer to as the standard normal distribution. And just like the book, oh, I'm not sharing this, am I? I should share so that Engage watches this 5 times again at work. He'll actually see what I'm talking about. All right. So this is the table here. And just like the table in the back of your book, it shades the area to the left, okay? So the idea here is Suzette got a score of 0.5, okay? And so as we go down here, you've got your z-scores in column A here. We're going down to 0.5, and so this first column is 0.50, 0.51, 0.52, 0.53, etc. Does that make sense? Okay? So Suzette got this score right here. How much better did you do, or what percent of people scored worse than you? Suzette? Yeah, 69%. So Suzette did better than 6.6915. Okay, so that's pretty. So that's still a good score, right? You did better than almost 70% of the people, right? If you were average, you would have done better than half the people, right? Okay, so we can actually look back again now that we see this, and we can see that Brady scored better than 84.13% of people. So this is going to be more accurate than the 68, 95, 99 rule. Okay, so we're just using that table. So on the homework, I'm going to ask you both to use the 68, 95, 99 rule, and I'm going to ask you to use the table. Okay? So
Could we do another one with the, just what we did?
we do. Let's in fact, we're going to base this on a similar thing. What score should we pick on, Brady or Suzette?
Let's pick on me.
Okay. What score does Brady need to get in the top 10%? Because 84% wasn't good enough. He's got to get to 90. Wants to be in the top 10%, right?
Yep. Being first or last.
Okay, so we're using the SAT scores again. Okay. So we're going to still use this chart, but here's the thing that I want to remind you, okay? I'm going to introduce you to a new phrase.